Okay, so we're going to be going over Math 2 4.5 flipped out, which is kind of like a continuation of what we've been talking about. So by the end of today, you'll be able to model a context using two different ways of thinking about variables and what are the characteristics of inverse functions. And so whenever we use this word model, the word model just means a physical representation of something. So when we say model a context, we're saying, how would we represent this word problem? That's all it's saying. So context means the story behind something. So like, have you ever heard that phrase when someone says, "Man, you took that out of context"? And so when they say things like, well, "You took that out of context," what they're really saying is, you took my words and you pulled it out of the context and you made it seem like I said this and I really meant this. Does that make sense? And so context just means what's around the actual story as opposed to, that particular thing. So we're going to be talking about this word inverse a lot. You will see this word inverse again in integrated three. You've seen this word inverse in the past when you were solving equations. The word inverse just means to undo. It just means to undo. So what's the inverse operation of adding? What's the inverse operation of adding? Yeah, exactly. Subtracting. So the inverse operation for adding is subtracting is because how do you undo adding? We undo adding by subtracting, right? That makes total sense. Okay. So what, Ms. Johnson, when you say inverse functions, we're just going to be undoing stuff. Right? And that's, if you think about the concept of math, math always does that. Like they first taught you how to add, and then they taught you how to subtract. And then they taught you how to multiply going forwards, and then they taught you how to go backwards using division. And then they taught you, let's see, squaring and then square rooting. And then they taught you earlier than that, they taught you how to use order of operations. Did you know that solving equations is the inverse of order of operations, right? That's why Miss Johnson says SADMEP sometimes. So we're just going to do more of that. And in fact, next year when you are in integrated three, you will learn two more functions, or one more function actually, and it is the inverse of a function you already know, right? So here's the next thing. It says Chandler and Isaac both like to ride bikes for exercise. They are discussing whether or not they have a similar pace so that they can plan a time to bike ride together when they find that they both think about bike riding in a different way. Chandler says, sometimes I have a busy schedule and it's hard to fit in a ride. I think about how much time I have to ride and then how many miles I can go. Isaac said, as I'm training for a race, I think about how many miles I need to ride and then how much time it will take. So if you notice here, they are thinking inversely of each other, inversely, meaning Chandler's thinking about time, like how much time do I have? Okay, that tells me how many miles I can go. But Isaac is going the opposite way, not opposite. I don't want to use the word opposite. He's thinking about it like inversely or in the backwards way, right? He's saying, I think about how many miles I need to ride and then how much time that will take. So they both look at each other blankly and decide to do a little mathematical modeling, right? This is what we all do. Use math to solve everything, kind of. So Chandler says, if I have 60 minutes to ride, okay, if I have 60 minutes to ride, I can go 12 miles. If I have 60 minutes to ride, I can go 12 miles. So here's what I want you to do. I want you to pause really quick. I'm going to pause the video. And I want you to model Chandler's way of thinking about her ride. Oh, I was thinking Chandler was a boy this whole time. Her ride using a table, graph, equation, and any other representation that you want. So here's a table for you. Here's a graph, or whatever you want to do. Exactly. From Friends. That's exactly who I was thinking of. Thanks. Okay. So if you start off with a table, maybe you'd say, oh, this is how many minutes Chandler has. So therefore, this is how many miles he's going to go. So can you give me a couple, maybe like 2 sets of entries, and then here give me a couple of dots, or if you want to write an equation, go ahead and do that. So I'm going to pause you. Okay. So here we put 60 and 12 because that's what they told us, right? What else did you guys put here besides 60 and 12? Yeah, someone cut that in half. Very good. If I only go for 30 minutes, how many miles should I go? Very good. Nice. Someone else put 120 here. Very good. So someone told me, okay, if I go 30 here, then Miss Jonathan, it must mean I go 6 here. Someone else said I go 120 here, and I go what here? What would I go here? Oh, 24. Very good. And so now if you see you have all this, in case you guys want it, I know you guys are all practicing how to do stuff in Desmos. I will say the better you are at using this tool, the better you are at understanding the math behind this. So every now and then I'm going to show you or re-show you. So if I wanted to enter this table in here so that I can get points on there, there's 2 ways to do it. The more straightforward way is if I just enter them as points. So I'd go 60, comma 12. And then you're like, hey, Miss Jonathan, I don't see it. Of course not, because this window is way too small. So I'll zoom out and I'll like change the window a lot. There he is. And so then I'll zoom him in a little bit. There he is. He's at 60 and 12, right? And then you can continue to put those other ones in there. Another way to do it is if you actually add in a table, and just how you did it here. You're going to go 60, 30, 120. And then you're going to go up here and go 12, 6, and 24. And as you do that, you'll see our points kind of show up in there. Okay. Very good. And it says, be sure to label each representation. So here's the graph. Here's the table. When they say to label each representation, by the way, they're asking you, like, did you label this part? Did you label this as minutes? Did you label this as miles? If I could label my axes, I would do that as well. So again, this would be minutes and this would be miles. Okay. So then let's see. Hold on. Give me 1 second. So then any questions on this part here? Pretty straightforward, right? So then I want you to practice using, in a second, we're going to go over here and we're going to do Isaac's, right, as well. So here's a couple questions. Explain the connections between the representations you found and how many miles will Chandler travel in at 30 minutes? We figured that out. And here's what is Chandler's speed? So I'm going to go back to this one because I already graphed it and I want to look at these things. So first they asked for what is Chandler's speed? What is Chandler's speed? So usually when we talk about speeds, like when when you're saying how fast you can go on the highway or whatever, you'll usually say miles per hour. And so I would just go right here with miles per hour because this is my hour, right? So he's going 12 miles every hour. So that's his speed. If you wanted to do it differently, like if you wanted to do what is it called? If you wanted to do a per minute, you could do that too. Minute is it's going to be really small, like not even, it's going to sound fun, kind of funny when you say that. So I wouldn't use minute in this case just because, and then the other question that they said was, can you draw some connections between this and this? Like, so obviously you see the points here, right? These points here are these points here. But do you see the slope of this like line? Do you see the slope of this line right here? And then do you see the slope of that line here? So the slope of this line here would look like this. Like if I could like pretend to draw. Hold on, you guys should remember this, right? Like, oops, hold on. Let me zoom in a little bit here. So if I was to draw this in here and this is like old school, right? This is like 7th grade. Your teacher would have been like, okay, well, draw your slope triangle in. And then you did this thing, right? Where you went up so much. I don't know, maybe like here. Let's just pretend maybe here. That looks pretty good. And then you would go over, maybe it was a little too high, and then over this way. Do you guys all see that slope triangle? Do you guys all remember that? And if I measured this out, because this is from here to here, from here to here, like this is from this point to this point. Notice here, I'm going up 6 miles. So I gained 6 miles. And then here, in 30 minutes. It took me 30 minutes to gain 6 miles. So if you divide that out or multiply it towards an hour, it would still be the same slope here, right? That would be the same slope of 12 miles per hour. 12 miles per hour. And you can see that here from 12 to this is 12 miles, and then you gained an hour. Okay. The last thing that people, let's see, I said this quote a couple times today, but George Polya was that mathematician that I was trying to remember. How did you get the table in my calculator? Oh, right here. So hit add. Oh, sorry. Let me show you. Hit plus and then table, and then it'll let you fill in the table as you go. But there's that mathematician George Polya. He says it's better for you to understand how to do one problem 5 different ways than for you to understand how to do 5 problems and always do it the same way, right? So this is like one of those examples where you're showing it in a table, you're showing it here, and for some of you, you even wrote an equation for it, which is good, right? So it's really important that you can make all those connections. Okay, so I think we answered these ones. Check. We answered his speed. His speed is the slope, by the way. If you didn't know or realize that the speed for let's see, for Chandler is his slope, right? Let me clear that off. Okay. So now on to slide 6, right? So in problem 4, they want you to do the same thing, except for now we're doing Isaac. Now Isaac thinks about it differently. He doesn't talk about how many minutes do I have to work out? He says, I need to do this many miles. How long is it going to take me? Okay. So I'm going to have you fill out the table. Do your best to try to fill out that table here too, to try to get the chart up here onto our graph. And then we'll answer a couple more questions, and then that'll kind of be it. Okay. Let me pause our video. Okay. So for this one, you had to switch them, right? Like this one, it's for every 5 miles. So this is going to be miles. Notice how this is reversed, right? They switched places. And this one's going to be minutes. Minutes. So here he says Isaac explains that he plans his bike rides based on the number of miles. So he knows that for every 5 miles, 5 goes here. He plans on riding 25 minutes, right? So if that's true, what else is true? So I'm going to open up this while I wait for you to tell me. If this is true, what else? Oh, someone says 10 and 50. This is pretty interesting because this is what my 6th graders are right now learning. They're right now understanding that if you have, and this is called a proportional problem, right? If you have a proportional problem, one that grows at a constant rate, that I could double both numbers and it's still going to be true. And you can even double the double. Or someone else put, hey, Miss Johnson, you can also go 15 and 75. And I think, wait a second, is that true? Let me see. Let me see. And I say 5 times 3 and 25 times 3. Yes. And I could even double the double, right? We doubled this. So let me just double the double. So this is 20 and this is 100. So this is true. This is something that you guys have been playing with literally since 6th grade. This is exactly what they're going over right now, which is pretty cool. I like saying to them, like, by the way, my 10th graders are learning this, but in a much higher level. So if you remember how to do this, then you'll be really, really good when you get to 10th grade with me. Okay. And then so they feel like, oh, so I'm going to see this again, right? So I'm going to basically take this table and copy it in here. Again, I hit plus and then I hit table. And then I like to enter the table going down. So 5, 10, 15, 20. And if you notice that 20 appeared on its own because it, like Desmos recognizes a pattern. And you're like, oh, Miss Johnson, you got to zoom out a little bit. So I'll zoom out until I see them. And then there they are. Right there they are in this line. And if you look at this one looks like, remember we talked about how, or maybe you remember from last year, this one looks like it's a faster rate than my friend Chandler over here, right? Because look at Chandler's. Chandler's looks like, oh, like a slower rate. But these two you cannot compare because if you notice here, this is minutes, miles. And over here, where are we? We are here, I think. Here we're going miles and minutes. So if you think about it, like the way this is doing it kind of goes like this. One of you is thinking about, I need to go buy some pencils. And then that person's like, well, I need to get 5 pencils. So they go up to the counter and then they say, okay, how much is it for these 5 pencils? And the lady says whatever she says. And then that's different than, right? Someone goes to the lady in the counter, and the little kids will do this. Little children will do this. They'll say, how many pencils can I get for this dollar? Do you see the difference between what you are asking and what they are asking? They're like, I have this much money, how many can I get? Right, so it's very different. So again, here's your table. Make sure you label it. They're going to ask you again to see the difference between here. The slope for this one is going to be different, right? Your slope will always be the change in y. So how much did you go up here? So hold on, let me grab my annotation tools. So how much did you go up here? So you guys are like, oh, we went up 25 minutes. And then we were able to go 5 miles. So notice our slope is going to be 25 divided by 5, which is 5 minutes per mile, which makes sense because I could actually enter that into my table up here. 5 minutes per mile, right? Which sounds like it's way slower than the other one, but he was doing 12 miles in 1 hour. Okay, so let's see what else we got. So over here, so we already did this part. So here's the problem. What is Isaac's speed? Okay, so let's figure out Isaac's speed. When we talked about this before, right? We talked about whenever you're looking at your dashboard when you're driving, it'll always tell you miles per hour. So does anybody see how I would be able to figure out how many miles per hour I would be able to figure out? Anybody see how many miles per hour? Anybody see how I can do that? And it has to do with what I was doing earlier. If you know that I can go 1 mile in 5 minutes, could I like find here, let's can I do this? Would you be able to tell me how many miles I would go in 60 minutes? Excuse me. How would you do that? Now, so you guys said you can multiply, right? So can you figure out this multiplication here? Can you figure out how to get from 5? Yeah, right? How to get from 5 to 60. Yeah, very good. So since someone said, hey, Ms. Johnson, you can multiply by 12 here, you guys know, well, if I can multiply by 12 here, that means I can multiply by 12 here. So this person he's also going 12 miles in 60 minutes. So who's going faster? Right? Because that was that question. Who's going faster? Or maybe I was jumping the gun there. Yeah. What's Isaac's speed? You guys figured this out, right? He's going 12 miles in 60 minutes. How is this different from how well, yeah, we did that. So, when we talk about Isaac's speed, his speed was also, we also said it was what, 5 miles, no, 5 minutes per mile. 5 minutes per mile. And then we said, who is faster? Well, we had to get to a place where we were being able to compare them apples for apples, right? So we made both of them have 60 minutes. How far did they travel in 60 minutes? And so then we figured out, oh, it's 12 because of how you guys multiplied here. Very good. So then we figured this one out. So really quick, if Isaac travels 12 miles in 60 minutes, how far is he traveling in 30 minutes? Very good. How far is he traveling in 30 minutes? Yeah, very good. 6 miles. Very good. You guys got this. So, like, sixth grader, you did a very good job because look at how much you understand, right? Using the equations, tables, and graphs for Isaac Chandler, make a list of observations about how these situations compare to each other. So, the last little thing that I want to do is I want to graph these two on the same. So let's see. There was another table that we had, and I wanted to add our table to that. So I think the table was minutes per mile, and I think he went 60 minutes in 12 miles. I'm just graphing them on the same one. I want this to be a different color. Oh man, I can't change the color. And then you guys said, I think you said 30, and you said this. I'm ignoring one big factor here. 30 and no, that's wrong. Can you guys hold on really quick? Okay, so I'm ignoring one very fatal thing here. Fatal meaning it would be a big math mistake, but I do want to graph them on the same plane so you guys can see what's happening. Am I doing this wrong? 120 and 24. So does anybody notice anything between these green dots and these green dots? These green dots and these green dots. Does anybody recognize the difference between these green dots and these green dots? Yeah, one is higher than the other. And I also want to graph one more thing and see if you guys get this. Right? Y equals X. Does anybody see anything interesting across this line? Does anybody see anything interesting? Yeah, it's almost like this and this are reflections. Yeah, very good. They're reflections of each other. They're reflections of each other. And so, because they're reflections of each other, that means that these two things are inverses. Now, I'm doing something really wrong here. The big wrong thing that I'm doing is that if this is minutes and this is miles, they wouldn't be reflections of each other because I'd have to flip one of them. But I wanted you to recognize that these were all, this is what we call inverses of each other. So good job on that. Okay. We did that. We did that. So let's do takeaways. Let me clear this up really quick. Okay. So when we're talking about takeaways for this one, the thing that I want to keep bringing you back to is here we did minutes and miles, but over here we did miles and minutes. So I always talk about inverses as being this guy's input is this guy's output. This guy's input is this guy's output. This guy's output is this guy's input. So everything switches, okay? Everything switches for this. So that's number one. So that's why the graphs were reversed. The other thing I want to talk about is, I think I put it on this one, is that these two graphs are reflections of each other across the line y equals to x. So when I say it's a reflection, I want you to pretend that I folded this graph over on this line. Do you see how this point matches this point? And this point matches this point? And this point match, well, no, I missed a couple points there. It says, so this says the equation of a function and its inverse undo each other. The equation of a function and its inverse undo each other. So when we talk about functions and inverses, we we have this undoing happening. We have this undoing happening. So like we talked about adding and subtracting. So here these were going to be very interesting. The last thing that I want to write out for you is when we write out a function inverse. So when we write function inverse, we say this is a function, right? This is the function. The way we write out function inverse is this: f to the negative 1, oops, of x. So this is how I want you to say it. Say it with me now. Function inverse. So please don't say f of negative 1 for this one. Please don't say f of negative 1 for this. Please don't say f of negative 1 for this. Please don't say f of negative 1 for this, okay? A lot of people mess up on this part because they think, oh, that's an exponent. So I know how to say this, Miss Johnson. It's f of negative 1. No, we say f inverse or function inverse of x. Okay. And the last thing that I want to say is, and you'll learn this later, two functions are inverses if you can undo each other. And we'll talk about that one later. I don't want to put it down because you'll see it later. But when you get to your exit ticket today, it says find the inverse of each function. And then when the function is given as a table, find the inverse as a table. So here, I want you to think about this is who is this? This is Chandler, right? This is Chandler. And you need to find its inverse. So just like we did Chandler versus Isaac, do you see how those two are related? Right? So here, I am going to show you this one. There's two rules of when you're trying to find the inverse. There's two rules. Uh-oh. Can you guys see my screen? This is good. Okay, good. There's two rules when you're finding the inverse. Number one, it's going to be switch x and y. And number two is going to be solve for y. Okay, so here we have two different variables. You're going to do the same exact thing. I'm going to do this exit ticket with you just so you know what to do. So the first thing it says to do is to switch x and y. Ms. Johnson, it's d and t. Yes, okay, so switch d and t. So you want me to switch d and t? Yes. So it's going to say t is equal to 5/2 of d. Is everybody okay with that? Switch it. So then what do I do, Miss Johnson? Then solve for the other variable. So solve for d in this case, Miss Johnson? Yeah, just solve for d. Okay. So how would you get rid of this 5/2 here? How would you undo multiplying by 5/2? How would you undo that? Yeah, you would just divide. Very good. And what would you divide by? Yeah, exactly. You would just divide by 5/2. I love it. Divide by 5/2. Some of you are like, Miss Johnson, I don't like dividing by a fraction. Okay, I'll show you an option. Give me a second. Okay, so your answer is going to be this thing. But do you guys remember back in 6th grade when you divide by a fraction, what are you really doing? What are you actually doing when you divide by a fraction? Divide by a fraction. Yeah, you multiply by the reciprocal, like this. You guys remember this? Yeah, you divide to cancel them out. So this 5 divided by 5 is 1, right? The 2 divided by 2, that's 1. So I'm going to multiply this. So you could either do it in blue or orange. I'm going for orange. So then t is equal to, oh no, the other way. 2/5 t, my bad, 2/5 t is equal to d. So there's your answer. Yeah. So the one thing that I want to make sure that you understand how to check is checking your answers. And I will show you that over here because I need more room than to do that. So let me show you on your exit ticket. Let me go here. Let me go here. Okay. When you do this, when you are doing this part, when you are doing this part right here, when you're checking your answers, I'm going after checking my answer. When you're checking your answer, you're just going to plug one into the other, into the other, into one, and to see if you get this. Okay. So for example, I'm going to plug this into here and see if it gives me the answer. So what do you say, Miss Johnson? So let me copy d equals to 5/2 parentheses. And do you see, I'm going to take all of this right here. Oops, I can't see. All of this and see if it cancels correctly. Okay, I'm going to see if it cancels correctly. So then I go 2/5 t. And does everybody see how this 2 and this 2 and this 5 and this 5 cancel? So when they undo each other, you're good. Good. You are so good. So there's some notation that I need to teach you about it, but I don't want to teach you. I don't want to overwhelm you. Here's the biggest thing that you are supposed to get out of today is switching x and y and then solving. This table you should be able to do in order to find that exit ticket. Okay, so this is just the beginning of inverses. We'll talk more about that for our next two sections. Okay.